Hello and welcome everyone. In this video, we are going to cover a question from the book Cracking the Coding Interview, and we are going to cover the chapter Arrays and Strings. So let's look at the problem statement. The problem statement says that you have to rotate the matrix by 90 degrees and in place. So you have been given an n cross n matrix and you have to rotate it in place by 90 degrees. So if you see this 2 cross 2 matrix, 1, 2, 3, 4, after 90 degrees it becomes like this. Similarly, you can see the examples of 3 cross 3 matrix and 4 cross 4 matrix. So you have to, let's assume, rotate it clockwise. Now let's think of the various solutions that comes in mind. So the first very basic intuitive solution comes in mind, that we can have another array where we can just copy 1, 2, the first row into the last column, the second row into the second last column, and so on. But in that case we will require some extra space, and here we have to do the in place swapping of the elements. So let's look how the solution would look like. So if we see this, the first row becomes the last column, the second row becomes the second last column, and the third row becomes the first column. So you can see that 0, 0 becomes 0, 2, 0, 1 becomes 1, 2, 0, 2 becomes 2, 2. Similarly, 1, 0 becomes 0, 1, 1, 1 becomes 1, 1 because it remains the same, and 1, 2 becomes 2, 1, and so on. So if you see this, y element is same as the x coordinate, whereas the x element, that is the 0th row, is replaced by the last column. Similarly here, the y coordinate is same as the x coordinate after the rotation. Also here, the y coordinate is same as the x coordinate here after transformation. So if you see this, we can form a relation that if some coordinate is x, y, after rotation by 90 degree, it becomes y, n minus 1, x, where n is the length of the matrix. So now let's look another example of a 4 cross 4 matrix. So here as well, the first row becomes the last column, the second row becomes the second last column, the third row becomes the third last column, and the fourth row becomes the first column. Also here you can see that y coordinate of the initial matrix becomes the x coordinate of the transformed matrix, and here the relation also holds true that x, y becomes y, n minus 1 minus x. Now one thing you have to notice that 1, 2, 3, 4 goes to the last column. So you cannot directly replace 1, 2, 3, 4 in the last column, because you have to store it somewhere so that you can easily swap. So if you try to replace one row at each time, then you have to store the values in the last column, that is 4, 8, 12, 6, to some array, and that means you have to take some extra space which will depend upon the length of the matrix. So we have to find out some other solution so that we don't need to use some extra space, and we can just use some swappings of the elements to transform the matrix. So you can observe a pattern here. So instead of replacing the first row with the last column, we can see that 0, 0 comes at 0, 2, 0, 2 comes at 2, 2, and 2, 2 comes at 2, 0. So there is a spiral pattern so that the elements are swapped by each of the position. Similarly, if we start with 0, 1, the final 0, 1 goes to 1, 2, 1, 2 goes to 2, 1, and 2, 1 goes to 1, 0, and the last element, which is 1, 1, remains at the same position. Similarly, let's take another example of 4 cross 4 matrix. So even in this example, so if you see here, 1 comes at 4 position, 4 comes at 6 position, 6 comes at 13 position, and 13 comes at 1's position. Similarly, 2 comes at 8 position, 8 comes at 15 position, 15 comes at 9 position, and 9 comes at 2 position, and the last spiral 6, 7, 11, 10 is also swapped. So you can see that the elements are swapped in layers, and the layer depends upon the length of the matrix. So if the length of the matrix is odd, there are n by 2 plus 1 layers, and if the length of the matrix is even, there are n by 2 layers. So in a matrix of 3 cross 3, there are 2 layers. In a matrix of 2 cross 2, there is 1 layer. In a matrix of 4, there are 2 layers, and similarly in a matrix of 5, there are 3 layers. So in this example of 3 cross 3 matrix, we observe that there are 2 spirals, and if we start with some element x comma y, it becomes y comma n minus 1 minus x. Then y comma n minus 1 minus x becomes n minus 1 minus x, because the y coordinate becomes the x coordinate of the next element, and similarly the pattern is formed. In each spiral there will be 4 pairs, and if you store the last pair, that is n minus 1 minus y comma x, to a temp variable, and you keep on replacing the elements and swapping with the help of temp variable, we can rotate the matrix in place. So I hope you have liked this solution and understood how we can approach this problem. I have attached the link of the GitHub code in the description section below. Please feel free to provide your inputs or suggestions in the comment section. Thank you.